In this video, I'll show you how to attach the sensors onto the robot. There are two sensors to attach. First, the line sensor with 3 pins. Second, the distance sensor with 4 pins. To connect them, I'm using these jumper cables provided with the robot kit. Take 3 of the cables and plug the female ends of the cables onto the male pins of the sensor. Note which color is out, VCC and ground. Taking a picture to help is a good idea. Turn the robot upside down and stick the sensor underneath. You can see that with the wires there, the caster ball is in the way, so I stick the sensor off to the side. The distance sensor has some resistors I need to attach for the circuit to work. I stick the sensor straight into the breadboard with the pins on all different rows of 5. The breadboard has rows of pins, where each row of 5 is all connected together, which means you can connect different components together by plugging them into dots on the same row of 5, so it's easy to make some simple circuits. In this case, the sensor needs 5 volts and produces 5 volts on its echo pin, but the maximum we can give to the Raspberry Pi is 3.3 volts. Therefore, we need a potential divider to turn the 5 volts into 3.3 volts. To make this, we need 2 resistors. The kit comes with 2 330 ohm resistors and 2 470 ohm resistors. You can tell the value of the resistor by the color bands on it. In this case, the 330 is orange, orange, black, black, brown. The 470 is yellow, violet, black, black, brown. You can look this up on the worksheet, which is linked in the description of this video. We need 1 of each. Bend the legs and plug them into the breadboard like this. Next, I'm plugging the wires in. I'm going to make a hole with a screwdriver, then widen it with scissors. As with the last build video, there are safer ways to do this. This is all I can do with the tools I have available. Feed the wires through and tape them down. Next, we stick the ultrasound sensor on top. Turn the robot upright again and stick the breadboard down at the front. Insert the 4 jumper cables into the breadboard. I'm using 5, but 1 is loose, so don't copy me. 4 is all you need. 3 cables should directly connect to the VCC, trigger, and ground pins, and the last cable should connect with the 2 resistors. You can see the 330 ohm resistor connected to the echo pin, and the 470 ohm resistor going from there to ground. The jumper cable goes in the same row as the 2 resistors. With the circuitry done, we can punch a hole for these wires, then feed them through. Now we connect the sensors into the control board. Feed the ground pin of the line sensor through to the distance sensor on top, and plug it into the ground rail. This is the orange wire for me. You can tape the wires down to keep them neat. Having the wires like this does limit how much the lid can lift off. Don't pull too hard here, as the cables have thin pins and can snap with too much pressure. Of the remaining line sensor wires, plug the VCC wire into 3.3 volts on the board, and the out cable into number 25. The last wires are for the distance sensor. Plug the VCC wire into 5 volts, trigger into number 17, echo into number 18, and ground into ground. That's it, all the wires connected. I have my loose green wire here, which you don't need to copy, but otherwise you can check how I've connected things. Here's another shot showing the numbers and colors more clearly. Next, we'll test the line sensor, then the distance sensor.